So good afternoon, everyone, and welcome to the second talk of the best practices track today, where we are going to talk about how to implement the PI system in the manufacturing operations, and especially on how to implement an OEE strategy. My name is Paula Baquer. I'm a customer success manager at OSIsoft, and over the last 7 years, I've been working with customers like you in order to help them deploy PI systems and work with them with different business cases to improve different items across their process lines, to have visibility end-to-end in the process line, to improve their quality of their products, to help them improve efficiency on their lines. And one of these topics, it has been, of course, OEE. Okay? So today, we are going to talk about this. So think about what are your manufacturing challenges on your organizations? What are those things that keep you awake at night? You are all smiling. For sure, you have many things in mind. Maybe it's something about downtimes, uptimes, or think about that time yet you run your plan so efficiently. What did you do differently? What did you do differently? Why cannot be just like that every time, right? So all these are challenges that each of you are facing every day at your organizations, and we decided to split them in 4 main ones that for sure you're all going to be very familiar with. First of all, it's about runtime. We need to improve the runtime, make sure the scheduled downtime is short as possible, and reduce the downtime operations across your organizations. But especially, you need to have visibility of what happens end-to-end, from raw materials entrance to product delivery. You need to have visibility on what happens in each part of your process, of your lines, of your equipment, and understand the reasons why you may have these downtimes and be able to track them. It's also about throughput. It's also about yield. Are you producing every time your product with the same yield? Is the same yield the same, let's say, in every batch for every product? How can you improve this yield? How can we make sure that each line has the right yield and we can plan better and ensure that by the end of the shift, we will have the throughput expected? Data will help us for this type of use cases. And of course, it will help us in order to improve our plan scheduling. By knowing when a shift will finish, we will be able to understand that product will be finally delivered, and we will be running with the capacity that plan can have, and of course, meet our demands that we have from supply, right? So these are all challenges that we believe you face day to day on your organizations. You are familiar with them, and today I'm going to talk to you about a project. We have been working with them since the beginning of the year. Over the last month, I will introduce you to Robert. So Robert is the director of operations for one of our manufacturing companies. They produce bearings. And he contacted us in order to improve their manufacturing operations in different sites because they just purchase PI in their organization. So one of the main reasons why they purchased the product was because they didn't have end-to-end visibility on their process lines. They were not proper understanding of how the process were working, and this was leading to have low product quality. At the same time, some machines were having failures every few minutes, and it was very difficult for them to understand and track the mean time between failures, as well as the different downtime reasons. So we need to investigate, we need to have data, we need to have visibility on the process in order to know that. Of course, we want to track these different downtimes, establish reasons for then know where we have to act in each process, in each line when we are producing, okay? So overall, they wanted to improve line efficiency, quality, have more uptime. So this looks like an OE strategy, right? This is precisely what they didn't have. So I'm talking a lot about OEE. Most of you, I believe, they know what it is, but just before going ahead on what was the solution deployed and the step-by-step recipe on how we can introduce that, let me do a quick recap on what this stands for. So OEE is what we call overall equipment efficiency, and it's a standard to measure manufacturing productivity that identifies the percentage of manufacturing time that is truly productive. It's calculated by the product of three main things: availability, performance, and quality. Availability is related to the running time. How much time an equipment can be running out of our all total production time. It's also about performance. Are we running at the maximum speed as possible, at the optimal efficiency of the line? And it's also about quality. Are we running, so we have the equipment running, we are running at the good efficiency, but are all the parts that we are producing good parts? We need to ensure these three things in order to have proper manufacturing. So if we had, let's say, 100% OEE, it would mean that we were running without stops as fast as possible and producing good parts only. These are the principles for lean manufacturing, and I believe each of you would expect to have 100% OEE in your organizations, right? The reality is that sometimes we have some losses. We have losses due to availability problems. So it means that maybe we have to stop the machines from time to time to do some adjustments, to do some unplanned maintenance. We also have problems in terms of efficiency. We are not always in reality running at the maximum efficiency as possible. Many times we have slow cycles, we need to restart the machines, the efficiency is lower than expected at those times, so this leads to different losses as well. And we have rejects. No, not always we are producing like at the maximum efficiency as possible. So we need to take these things, if we look at it from, let's say, from a time perspective, and all the possible time, so 24/7, 365. First of all, we need to reduce the time that we spend, let's say, with already scheduled losses. We don't take this into account, but we need to take into account for OE calculations up or from all the running time. We will then have losses due to availability, losses due to performance, and some losses due to quality, of course. So out of all the time, maybe at the end, the real production time, which produces good parts, is quite small. Correct? So this is precisely what was happening to Rob and his organization. So he involved us to work with his engineers in order to understand better the processes and establish these metrics to be able to compare what was happening across his organizations, across his sites, across the world, and within the different lines. Okay? So we worked with him to define some visuals that were interesting for him, and not only for him from a higher level, but for different people in the different plants in order to establish that. So, okay, first of all, I'm talking about bearing manufacturing. Not sure if all of you know what it is. Basically, they produce these pieces over here. And these pieces over here are produced through three main lines, different type of line processes. One that is doing the inner ring, one is doing the outer ring, and the other one is doing the rolling equipment. So Rob had different sites. We worked mainly in one of them, but the outcome was that then he could deploy this easily across the different sites. So at the end, he could see his sites here where they had information, he had information of the sites from APAC, in Japan and Korea, and then also in in Germany and in the US. So if we'll deep dive into one of the plants, we will see that for him it was very important to know what was leading to these low OE parameters. So we went, I'm going backwards, but we established OE calculations at the specific equipments. We bring it up to the stations, to the lines, and then to the sites. So different people across the organization can actually see what is important for them. For him, he wanted to see how is it across the different sites, but he wanted to see as well from each of these lines what is leading to lower efficiency. So for the inner ring, outer ring, and rolling elements, we can see a summary of the different lines here. You see numbers that actually they are not too bad, right? They are still quite close to 100%. I think for some industries this is a lot. Especially, I think you have there are some pharma customers here which sometimes can be quite low, even like difficult to reach the 50%. But for them, this was not enough. He wanted to understand why the inner ring had lower efficiency, why were the reasons of the performance low efficiency, for example, of this line. So of course, we deployed Pi across the organization. He could see the different parts of the site, and he said, okay, it looks all good, but in reality, it's not so good. We need to investigate a bit more. What's the problem here? So this was not enough, so we built something like this. What can we see here? We can see for each equipment information about OE, but most importantly, also by lines. So inner ring was one of the things that was making him a bit annoying. It was what he wanted us to investigate because, in fact, they were having lower performance on that ring. So here in the table, we can see all the equipment on this ring and what exactly can be leading to lower performance. They wanted to calculate this over our time frames, but we can calculate this over the certain period of time that we want. So if we look into these equipments, we can see that maybe lathe 4, lathe 5 are the ones that have normally low performance, and they could have low OE values in the line. Okay, and we could also see in detail the lathe 4, for example, here, but by using this type of drop-down menu, we could change this as well and go asset by asset. So how did we implement this? This was very easy to do, and this was done in just a few weeks. But most important thing is to follow this recipe. So first of all, most important, we need to be able to connect the equipment. Problem was the site. These equipments were quite, they were disconnected from the line. So first thing we have to work on is making sure we can connect the equipment. We can do this through the standard control systems, or you heard in the morning that we are also promoting all of these IoT sensors. So connect your systems, have your data into the Pi system, and then contextualize your data. We can contextualize our data by establishing templates in order to be able to compare different types of equipments. And finally, we establish some logics to perform our analytic calculations. Because the equipment doesn't give you the OE calculation, it's you that you have to build it. Okay? So what would be next? We need to track all those events, all those downtimes, in order to identify similar parameters across your different lines. And finally, visualize it. We saw some examples in Pi Vision. We're going to see more in Power BI or other advanced analytics tools later. Okay? So if we go step by step or a bit more in detail across how we did this, I would like first to introduce you a bit more his plants. Okay? He had, as I said, different lines. He had different lines where they were producing, where these lines had different equipments. First of all, the inner ring had 2 main stations and a heat treatment. Then we had also the outer ring with different equipments, different stations as well. Some equipments may be similar, some others are different. And then we have the rolling element. Rolling element has also different equipments, but at the end, the idea is to be able to establish some calculations that can be then used for all of them. So we have the equipment. We understand how is the plant. We let's go and connect it. Next thing we did, of course, if we go one by one to one of the steps before, so I'm going to navigate you on a bit more detail on how we did that. So first of all, what we did was to connect the different equipments. We understand the different lines. We connect them, and we connect them into the PI system through the SCADA, PLC, or DCS. You may have OPC on your cases, Modbus, different type of information to get the data from your interfaces into the PI system. But the data that you get from your equipments is data, so real-time data of the equipment, so the number of rejects, if the machine is on or off, what is the speed, and so on. So we'll need to use the context of the system and the different analytic capabilities to then deploy your solutions, your OE, your specific KPIs that you want, and then you, of course, need to scale it up from your equipment to your line, and then to the whole plant, or even organization, if you want. So we have connected the equipment. Next thing is to get the context. We have different lines with different equipments. We want to build a template that is user-friendly then for visualization and for reporting. So we have to use the advantages of Asset Framework in order to build this for his users. So with the PI system, you can have different views. You can have view by equipment list or view by areas. In our case, we built both because there were different use cases for each of them. So we get the data, we put the hierarchy, and then we can get the data of all of these different pieces of equipment. But when we build one of these assets, we have information not only about the real-time data from the equipment, but we can also bring some other information. We can bring information about the asset type, about the last maintenance day, about many different type of static information that could be useful also for you then for future analysis and exploration. So as I was saying, something for asset management, for maintenance, and of course, real-time data. So we have the data into the system, we establish the context, then we need to do the calculations. Very easy. With analytics, we can establish the OE metrics in order to calculate the different type of parameters. We established these rules. It was useful for them to work on this, but in order to establish your calculations for availability, performance, quality, you need to understand how the machine work with the different people who are in charge of this machine, and make sure that you establish these rules in analytics. Once you have this, you implement it, and then you can establish your calculations in your templates, and then deploy this across your site. So we have data in, we have context, we have analytics. What's the next thing? Yeah, will come, visualization. But first of all, we have this for equipments, and we want to visualize this not only for equipment, we want to see it for a station, we want to see it for the line. So we leverage the power of the templates and roll-up calculations to scale it up for those different pieces of equipment. So initially, we had information for each of one of these equipments. We established this at the template level. We went ahead, and finally, we roll it up at the line. This is very interesting to do it. For example, if you want to calculate the minimum OE of one of your areas of your line, you can establish this type of calculations to see what was the minimum over a certain shift or over a certain hour. This is very interesting for you to use it. In this case, we establish it also this way. So very simply, in analytics, you can make use of the roll-ups in order to do this type of calculations, where it takes all information from the different equipment you have in the line, and you roll it up to the asset above it. So we established this, so we arrived at this point that we had the data. We could also get some data from the past, what we established the calculations today. So what would be the next natural thing to do? Okay, from now on, we have OE calculations. But no, with the BI system, you also can get data from the past. We have the option to backfill your calculations, backfill your data, so we managed to have a view of what happened on these equipments over the last year, for example, which was interesting for them to do more analytics on their data. Okay, so I encourage you to use that with the backfilling options as well. So next thing to do, I know you already seen it, but would be to track the different downtimes, no? To track the different downtimes, establish reason codes in order to know not only, so first of all, to know when a machine stops and be able to see what are the typical reasons why those machines stop. So we used event frames for that. In event frame, you can establish context, start and end time, and then you can use them to compare your assets, to compare similar behaviors, and of course to track downtimes, which is, I think, the most interesting thing of this part as well. So we established this, and another thing that it's very important to do, and I'm not sure if all of you are familiar with it, is to establish different reason codes for the different equipments. So reason code is both useful to establish some type of metrics on the different status that a machine can be, but it's also interesting to establish some rules that then your operators or your engineers can put when they experience a failure. So they classify it in a way that then is easy to do and to understand for your different, when you do your investigations as well. So we can have, for example, reasons as mechanical failures, on other OE reasons like, I don't know, equipment failure, it was for a small cycle, minor stops or something like that, so you can then classify them better. So at the end, we have this all tracked, and we can visualize the data. And we can not only visualize the data based on we can visualize the data based on OEE. I showed it before by lines, but we can also classify them, let's say, based on equipment types. So let's say that I take all the board grinders. I can see that maybe the 004 in station 5 has lower performance now that they are running. So why could be that? I can go and investigate what can be leading to this performance. So we build this in PyVision. I believe you all are familiar with PyVision today, but one of the capabilities that you can do is to use multi-state symbols in tables as well. And this will help you to have this type of nice visualizations. And you can establish these metrics also in your KPI parameters for OEE. Also, by tracking different events, you can establish reason codes, acknowledge them, or even put some comments. So people can access to them and establish this information there as well. And also, for the ones that maybe not have a BI platform yet, or they want to do first analysis using the standard tools that you have in your organization, you can also export all your information about your events in data link. So when you export this information about your events in data link, you can also establish some type of pivot tables and be able to have a bit more insights. So for example, we could see that out of the total failures that we have, okay, there are some that we don't know. We need to investigate a bit more because we cannot find the root cause, but some of them are because of reduced speed or some equipment failures. And if we look into the different manufacturers that we have, it looks like the one more affected is Takizawa. Another view that you could have is what are the main reasons of the different lines, or also seeing this information based on different assets. So it's very simple. You just establish your information, let's say, into this PI. You put the context, you bring this data out, and you can visualize this in simple tools like PyDataLink that will help you to do your first analysis. But we actually like more maybe this type of dashboards, like more type of slice and dice, drill down capabilities, Power BI type of platforms. You probably, I don't know, you may have ClickView, Tableau, or any of these. So we can bring the data into this type of tools in order to investigate a bit more what happens across your organization. So we did this in this experiment as well. We got data for a specific period of time, and we were able to establish, okay, to visualize this information there. And in fact, if we were analyzing the different, lines, it looked like one of the rings, in fact, was having lower performance. In a ring again, we want to use this type of template to drill down. So if we would click into here, we can actually navigate into what are those stations in the inner ring that are leading to lower performance. So it looks like that maybe station 1. We didn't have this information before. We were just guessing. We were just doing tweaks and tricks in each of all our equipments when we had a feeling that a machine was not working well. So with that, we can see it with data, we can quantify it, we can analyze it, and take some actions. Also, okay, we have this information on station 1. Station 1 has these lathes, for example. So we could also have a view based on equipment and overall equipment analysis. And it looks like that effectively lathe 4, which was on that station, is the one that is, in fact, causing all our problems, all our headaches, and is the one that is leading to lower performance on that line and overall on the site. So now we need to know, so we know that we need to take some actions, see this machine or act on this machine with a bit more carefully, analyze what's going wrong in order to understand better the machine KPIs and do some action on them. Because many times we just operate the machines by feeling of the operator and without data. So this gives us the insights to know where we have to focus our efforts, let's say, in our next projects, where we have to put our budget, and this is how we also can help it justify to the plant manager, for example. So why I did want to show you also this type of visualization? This is because we have PI integrators that enable advanced analytics for you. Advanced analytics, for me, I normally classify it into many things. Be able to build dashboards like that to correlate information, but also to apply algorithms to then do some predictions based on your data. The so-called machine learning part of the artificial intelligence, let's say, science, that is what will transform our organizations in the future. But in order to use this type of technologies, we normally need really organized data. Data in a tabular form that will be able to, so that this process or this type of products can ingest it very well and build, let's say, your reports or your algorithms. The truth is that most of the times, data doesn't come such well aligned. Different equipments get data at different times. You may have some failures, you may have different frequencies, you may have some data missing at some points. So with the PI integrators, we can actually shape the data on the right way in a tabular form in order to be consumed by these products. So, having said that, by just having visibility across their plants, we could have results in just 3 months. So first of all, we understood better what was occurring in the plant, what was occurring in the organization, and in just 3 months, they were able to improve performance 40% on those equipments. They were also able to increase availability by 21%, and at the end, they had an OEE improvement about 30%. And this was just done by understanding better, having visibility on their processes, and know where they have to act when a lower of these capabilities was studied by the engineers. So, as a summary, what were the main challenges, what did they do, and what was the success of that? First of all, difficult to reach the production targets because they didn't have visibility across their processes, across their organizations. They were not able to track downtime reasons. It's not that today they already know all the reasons of their downtime, but they have more insights now and they can classify them for further studying. And how did we do that? We implemented a very easy 5-step recipe where we got our data from your different equipments. We capture it and contextualize it. We established some standards to be able to compare this data, and we were able to build some dashboards to have visibility across the end-to-end parts of the plant. Of course, we used a platform that enabled them to do this. And they were the owners of that platform, and they were the ones that they established the rules in order to do that. Because at the end of the day, the people working operations on the process lines are the ones that actually know better about their processes and can establish better these rules. And what were the benefits at the end? So we managed to increase capacity on the site because we can produce more. We can also have better efficiency. And of course, we will have, at the same time, more quality products at lower downtime and be able to optimize, of course, the different start times. And at the end of the day, we can also have less product rejects and know better our organization and our plant. So, what about yourself? Do you have strategies like this on your organization? Yes, some of you yes, some others are laughing. So you can see that with the PI system, it's very easy to start. Take a site, take a project, take an equipment that is bringing you a lot of headaches and start working on this, because it will be the first step to transform the different parts of your world, of your daily basis, and of your plants. And all of this thanks to the power of data. And I would like to help you a bit with that. And for that, we have some resources that can help you as well for you to kick off your projects. We have a full community, what's called Pi Square, with many examples. We have many examples on how to start using asset framework, how to start establishing your OEE calculations, and you can find many preset examples there for you to download, test it in your equipment, and copy it in a similar way. Also, we have lots of partners who work with us in order to help you also improve your operations. We provide you the infrastructure. We provide you first level layer where you can capture your different equipment information, establish your KPIs, establish your first OE calculations, and we have PyVision to visualize first information. But there are plenty of partners out there that can help you implement this solution, and they have very customized own solutions that you could also see and evaluate for your organization. So don't forget about the whole partner ecosphere, and you can find them also across the booths today. And if you would like to know a bit more during these days, don't forget that we have labs. We have some labs on Thursday where we can also be focusing on how to improve performance across your assets. You can go there on Thursday morning, if I'm not wrong, and you can establish and put hands-on system like that, use case like this, for you to be more familiar then when you go back on Monday to your plants and start thinking how can we deploy it in our equipments. So with that, here you have my contact details, and I would like to thank you for your time. I hope you enjoyed the talk. There are plenty of more talks to come, and don't hesitate to ask us any questions if you need. It's a journey, and this is just 4 hints to help you start. But I encourage you to start because you can see results very, very fast. And we have then, of course, plenty of customers to share their stories as well, which many of them are already here also in the conference too. So thank you very much and enjoy the rest of the conference.
Questions? Does anybody got any questions? We can take questions for a couple of minutes. Can't see for the lights. Put your hand up if you want a question. Nope, here we do. Okay.
I'm Loïc Jean from Chevron in France. My question is about to capture the reason code. When we have defined the reason code in the system, how the operator can input the reason in which system, in which software, to after use this data?
In PyVision, you can establish, for example, event tables. And when you have for these specific events the option to establish a reason code, you can select them from there. Yeah, it's not shown in the presentation, but if you go to the booth, they will show you the exact steps on how to do it. It's very easy.
Any other questions? No? No more questions? You can always come and grab me or Paula. Oh, going over here.
Hi, I'm Thomas Reiterer from RHI Magnesita. I have one question. Where from do you know that is a planned production time or it's not planned?
Sorry?
The planned time, scheduled time.
Yes.
Where from do you know this? Is it also a manual input or do you have an SAP or something where it's scheduled?
Well, it's part of the planned schedule. So out of that, you need to, let's say, reduce the specific time that is already, let's say, scheduled for maintenance. So we don't take into account this for the OE calculations. So when we establish this, we can also put some rules to just take into account when the plant is on. And we can establish this by putting some conditions on, or you could link it, I don't know, with a table, for example, where you can actually see what is expected production time or not and relate this with your analysis. So there are different options to do that.
Thank you.
Yes, hello. I'm Floris van Zwaard from CGI. I was wondering, how do you calculate the quality?
Yeah, well, the quality, we need to always reduce from the good parts the reject. So out of the total expected parts, we need to take into account what is the reject ones and establish some logic in order to implement this there. So it might depend, you know, from company to company, because maybe some companies then you may recycle this information and you can introduce it back into the process. But for this case, it was quite easy. It was just take into account, just remove the rejects. Of course, it's something that you need to discuss with the people who are experts on the process to establish the right calculations for that.